intentionally gave you a problem like this because it makes you think about what you're doing with absolute value, as well as forces you to work with fractions, because a lot of students are afraid of fractions, and fractions is something that you're going to keep encountering. So what I want to show you is there's a quick and easy way to deal with fractions. So we want our absolute value to be by itself before we can set up branch 1 and branch 2, which means that we have to get that 2/3 out of there. Now 2/3 is being multiplied, so I want that 2/3 to equal 1. Well, if I multiply 2/3 by 3/2, then that's going to give me 6 divided by 6, which is the same as 1. So that means that I do this to one side. I'm going to also multiply it to the other. I'm going to squeeze it in right here in the front. 3/2. Okay? So what I want you also to realize is that this x minus 2 is one number. So remember, if I were multiplying something like, let me give you an example off here on the side. So if I was multiplying 3 times 2 times 4, I would multiply these two numbers first, and that would give me 6. And then I would multiply these two numbers here, and that would give me 24. So it's the same sort of idea here. This is one number times another number times another number. So I'm only multiplying this 3/2 to one of the numbers. Doesn't go to everything, it just goes to one of the numbers. The way this 3 only went with the 2 and I got 6. And then the 6 went to the 4 and I got 24. Same sort of idea. And we'll see more and more of that as the year progresses. So that means that this divides out to 1. So that's no longer there. So now I have the absolute value of 3x minus 6 equals, well, you could multiply this together and say 3 times 4 is 6 divided by 2. So that's, 3 times 4 is 12 divided by 2, which is 6 times x minus 2. That's one way of doing it. Let me move this over to the side and let me go over that again. So if I have 3/2 times 4, you could say that's the same as 12 divided by 2, which is 6. The other way you could do it, I always say simplify before multiply. 2 goes into 2 once, 2 goes into 4 2 times, so that equals 6. Either way, it works. Okay, so now I have my absolute value by itself. Right here, all by itself. So now I can do branch 1 and branch 2. So branch 1 is as is. 3x minus 6 equals 6 times x minus 2. And branch 2, remember, I'm going to take the opposite of what I see inside the absolute value. 3x minus 6 is equal to 6 times x minus 2. So let's go ahead and solve branch 1 first. So in this case, I want to distribute both through. So I'm going to distribute 6 to x into negative 2. So that gives me 3x minus 6 is equal to 6x minus 12. Now I'm going to subtract 3x from both sides. I planned ahead on that, and I saw that If I were to subtract 3x on both sides, that's going to give me a positive x value on this side. That's why I chose to go that direction. So bring this down. I have a negative 6 is equal to 3x minus 12. I want to get like terms together, so I'm going to add 12 to both sides. So that means this is going to give me 6 is equal to 3x. Divide both sides by 3. And I get x is equal to 2. That's a possible answer. So let's go ahead and do the same thing. I'm just going to put a line under that. I'm going to do the same thing to the other side. Okay, so in this case, just because it's ugly all the way around, let's go ahead and distribute that negative in on this side. So I'm going to get negative 3x plus 6 equals, and then I'm going to distribute the 6 in on both sides. So that's going to give me 6x minus 12. Okay, so because this 6x is bigger, I'm going to add 3x to both sides. And that's going to give me 6 is equal to 9x minus 12. And then I'm going to add 12 to both sides. So remember, I want to get all my like terms together. So that's going to give me 18 equals 9x. Because I want to get x by itself, I'm going to divide both sides by 9. 9 goes into 18 2 times. So x equals 2. Isn't that funny? I got the same answer for both branches. Okay? So perhaps I should test this, because it was kind of a funny looking inequality to begin with, excuse me, an absolute value problem to begin with. So perhaps I should test this to make sure that nothing weird is going on. So let's just go ahead and do that. So with my testing, I have my absolute value of 3x minus 6. Oh, there was a 2/3 in the front, right? Equals 4 times x minus 2. So remember, with testing, I'm going to do PEMDAS in the normally learned direction, order of operations like that. Okay, so I'm going to substitute in my 2 here. So this is 2/3. 3 times 2 minus 6 equals 4. 2 minus 2. Okay. So this is going to give me 2/3, the absolute value of 6 minus 6 equals 4 times 0. So that's going to give me 2/3 times the absolute value of 0 equals 0. The absolute value of 0 is 0. So this gives me 2/3 times 0 equals 0. Which gives me 0 equals 0. Okay, so for my answer, I get x equals 2.